So here in this topic what we are going to do is we have two things. So one is the private address, another is the public address, so public IP. So generally we have two things, private IP address and public IP address. Usually private IP will be this is to solve the internet IP addressing issues, because let's say for example in a campus if you have 1000 computers, all the 1000 computers need to be connected with the internet, means we cannot purchase 1000 IP addresses, public IPs, because public IP is too costly to handle it. So instead of that, what we do is one public IP we can able to purchase it, and we can give the private IP, and using the NAT, network address translation, we can map the private with the public so that the purchasing of IP address will be limited. So that's how the way we can optimize the addresses usages as well as the money we pay for the IP addresses. So that concept is called as network address translation. Now we can see that the growth of internet need more IP addresses. So as we more and more internet devices are added to the system, we need more IP addresses. So one deeper hierarchy, you can see country, state, district, LAN, host requires more than 32 bits of addresses. For all these things we need more addresses. So we have long term goal is one method is to go with IPv6 addressing. This is the best thing which is possible, but currently we go with one thing called a short term CADR, that is the classless inter domain routing. So that's what the CADR we can go for. So we use the slash notation 8, 24, 27 like this, that we can able to do. Another thing is the network address translation, NAT, in short we call it as. So now you can see if the business grows or the household needs a larger range, in most situations only a portion of computers in small network need access to the internet simultaneously. The ISP may not be able to grant the demand, because ISP means internet service provider, they cannot be able to make the demand. That means more IP addresses need to be purchased, because addresses before and after the range may have already been allocated to other networks, which is very tedious. So the distribution of addresses through ISPs have created a new problem. So because of this problem only, we just opting for a network address translation. Now in the network address translation we can have these things. So address translation, translation table, private IP address and routable IP address. So these are the four things that we can able to do on a NAT, network address translation table. Now you can see this here, this is a private network, the yellow colored ones are the private networks. So you can see here, this is a private network and this is a private network, okay. And the address translation table, you can see it is here, this is a translation table, and see the IP addresses here. So now the S is SD, so the S will be the source address and D is a destination address. You can see the source address is 25.8.2.10, destination is 172.18.3.1. Similarly here the source here is 172.18.3.1 and the destination is 25.8.2.10. So you can see the data moving. So number one is the make the table entry. So first you make the table, this is the table entry. So in this the private address is mapped with the universal or the global address 25.8.2.10. So usually 172 series will usually be a private address. So likewise this is a network address translation table, NAT table here. Now number 2 is either change the source address. Number 2 is, so here you change the source address. So source address is changed to 200.24.5.8 because of the routing address there. Then number 3 is access table. So here this is the access table. So from this here, how the data is accessed is, the source is mapped with the changed address, that is a routing address. So 25.8.2.10 is mapped with it here. So this is number 3 here. Number 4 is change the destination address. So here you change the destination address. So this is how the way the complete mapping is done. Number 4 is change the destination. You can see that the destination is 172.18.3.1. So this is how the way the entire networking is occurring in network address translation table, NAT table. This is the NAT table. So based on this NAT table only, everything will be handled here. So first thing is the source and the destination. So we know what is the destination address, we know what is the source address. So source and destination is mapped here, which is then given there. And here number 2 is the change the source address. Source address is changed to the routable address 200.24.5.8, which is then entered into the translation table. Then whenever we access the table, we access it with the help of the source and the router address, that is the destination address. And finally that is mapped with the private. So the outside domain will be knowing only one routable address, which is called as the 200.24.8.5. So this is the outsiders can able to find us. So the outside network find us through this IP address, and the source IP address is 25.8.3.10. Once it comes inside the campus, which machine is having the internet will be fetched using this address. So this is how the way the source and the destination will be mapped. So this table only we called as a NAT table. Now we can see here the private IP address here is this, and the routable IP address is this. 200.24.5 is a routable IP address, and 172.18.x.y is a private. Now we can see that the NAT router is here, the table where it is. From the internet, you see that this is the routable IP address 200.24. This is the routable. So this address is given here. Okay, and you can see the private IP address 172.18. This is the private IP address 172.18, which is then given to all the other networks 3.1, 3.2, or like that up to 3.20. All the computers have been having the internet. So in our campus also, this same kind of methodology we usually follow. So all our campus IPs have been fixed as 172.16. So this is how the way we have just fixed. Similarly, in the second case here, destination is this and the source is this, and you can see how 3.1 here and here it is 3.1, how the packets are moving from here to here. You can see that. So first it moves from here to here, then after that from the internet it again comes back from here to here. It just come back here from here to here. So this is how the way the network address translation is working out. Okay, so now we have some special IP addresses. So you can see the special IP addresses, because private address, all addresses cannot be private. So globally they have fixed 4 private IP addresses. One IP address starts with 10.0.0.0, 172.16.0.0, 192.168.0.0 and 169.254.0.0. So these 4 range addresses will be never be given as a public IP. So public IP they won't be given. Public IP is always wrong. So these are all the special private addresses. So these IP addresses is mainly for the private addresses. So you can go to any campus, any universities, any institutions, any companies. When you go locally, internally, when they have a networking, so they have either of these 4 addresses as private addresses. Okay. So another option is, instead of NAT we can go for the long term is the IP version 6. So why we need an IP version 6? Depletion of address in IP version 4 is already depleted. Larger address space we will get it. The slowness of the process due to some unnecessary processing headers, the desperate need for security confidentiality. So because of this we need to go for IP version 6, because IP version 6 by default have something called as IP security, IPsec we call. So which is by default to be integrated along with IP version 6. But in IP version 4, IPsec is not mandatory, but it can be an add-on. But in IP version 6, IP security is the mandatory one. Now the planet Earth is approximately 2 power 60 square meters. So we need more addressing, 128 bits address we can able to build. So you can see that how the IP version 6 address looks like is number 1, 2, 3, 4, 5, 6, 7, 8. So 8 into, so totally you can see 8 into each will be 16. So 16, this will be 16. So 16 is nothing but 128 bits. So totally you will get 128 bit addressing in IP version 6. Okay, so totally if we can assign, we can able to assign up to 2 power 60 addresses each year. So this is what the advantage of IP version 6. And one more here is, it will take 2 power 68 years to deplete addresses. That means you cannot count that. So zero compression in IP version 6, already we have discussed this in our class. So if you have a double colon, if it is available in between it, so the double colon will be replaced with as many as zeros possible in IP version 6 address. So you can see 0 compressed is the right hand side. This is how it looks like. Original address is looking like this. So we can able to reduce the IP address compression with filling up with zeros. So you can use this double colon. So in this double colon is replaced, can be like this. Yes, these are some of the examples of IP version 6 you can go through. So thank you students. So we have seen 2 videos. So one video is on classless addressing, another video is on network address translation table, and a brief introduction of IP version 6.